All right, the blessed power formula is here. So, all those longhand derivatives we've been doing, don't have to do them anymore. Except for maybe like once on the next AP test. But, basically, the power rule says, if you have a function raised to a power, then the derivative, so d dx stands for derivative, the derivative of said function becomes the power in front, and then you subtract 1 away from the power. Now hopefully this one is obvious and we've figured it out, but if not, the derivative of a constant is 0. So the derivative of a constant is 0. So remember, the d dx stands for the derivative of whatever the function is with respect to x. So d dx of c is 0. It means the derivative of a constant is 0. So for example, the derivative of 14c would equal 0, where c stands for any constant. So two constants being multiplied together would still have a derivative of 0. Derivative of pi, 0. And then over here, the power rule. So this is x to the 4th. The derivative of x to the 4th, the power rule says the 4 comes down in front. So it becomes 4x. And then you subtract 1 away from your power. So you get 4x cubed. Here, the power rule is 12x cubed. So again, you take the power, you multiply it by what's out in front. So 12 times 3 is 36. Subtract 1, y squared. They're jumping around upstairs again. Great. So use the power rule to find the derivative of f of x. So when we find the derivative of any function, we take f and we rewrite it as f prime x. So f prime stands for the first derivative. The derivative of any constant is 0. The negative stays with the 2. So an x is to like the power of 1. My board is really off calibration-wise. So you take 1 times negative 2, you get negative 2. And then that would be like x to the power of 1 minus 1. So it would be x to the 0. We know anything to the 0 power is 1. So that negative 2x becomes negative 2. Plus 4x squared. So the rule is the 4 multiplies by the 2. And then you subtract 1 from the 2. So you get x. So we get f prime of x equals negative 2. Multiply the 4 and 2 to get 8. And that's to the power of 1. Okay? So d dx, again, fancy way of saying the derivative of x. So 1 over x cubed. We don't really have a rule for when things are in the bottom yet. So we're going to rewrite that as a negative exponent. So we're going to take the derivative of x to the negative third. So you take the denominators, bring them up as a negative power. So now the rule still applies. Whatever the power is comes down in front. So you get negative 3. X, and then our rule is that you subtract 1 from your exponent. So you get negative 3x to the negative 4. In math, we try not to have negative exponents, so we'd rewrite it as negative 3 over x to the 4. Okay, derivative of the square root of x. So once again, we would rewrite the square root of x to an exponential power. So the square root of x, because our rule is for a power, so we need things to be in terms of powers. The square root of x would be the 1/2 power. and then our rule of thumb applies. So you bring the power down in front, subtract 1 away, so it'd be 1/2 x to the negative 1/2, and then we just clean it up, and we say, okay, 1/2 x to the 1/2, or you could say 1/2 square roots of x. Okay. The power rule does not apply to a quantity that is a binomial. So the power rule does not apply to a binomial being squared. You can't just say that this is 2 times the quantity of x plus 5, because sometimes the inside stuff will affect your derivative. So if you have two things that are being raised to a power like this, we need to rewrite it where we FOILed this out. So then derivative of x squared is 2x. So you bring your power down in front and subtract 1 away. Derivative of 10x is 10. The power would be 1. Taking 1 away gives you 0. And the derivative of a constant is 0, so it is gone. So the derivative of x squared plus 10x plus 25 is 2x plus 10. So again, a quadratic turns to a linear. Quadratic turns to linear. Any questions so far? There's no Michael asking. Okay, so then obviously, like, everything in calc doesn't stay easy. It's not just, oh, hey, we're going to do power rule forever now. No, what they do is they would ask you an extension question of the power rule. So it might be, does the curve y equal x to the fourth minus 2x squared plus 2 have any horizontal tangents? So a horizontal tangent would be essentially a extrema. So a horizontal tangent would be where the slope of the tangent line is equal to 0. So when is the slope of the tangent line equal to 0? Well, that occurs at an extrema. So any horizontal tangents would occur when the slope of the tangent is equal to 0. Well, how do we get the slope of the tangent? Well, the slope of the tangent comes from the derivative, right? So definition of the derivative was limit as h approaches 0 of f of x plus h minus f of x all over h was equal to the slope of the tangent. Now we have a power rule. So now the slope of the tangent is really the same as the derivative. So y prime is the same as the slope of the tan. So y prime, in this case, using our power rule, the derivative of x to the fourth, bring your power down in front, subtract 1 away, so you get 4x cubed. Derivative of negative 2x squared, well, your power comes down, so you get negative 2 times 2, so you get negative 4. X, take 1 away, get the power of 1. Derivative of 2 is 0. So you get 4x cubed minus 4x. So then the question is, does that have any horizontal tangents? Well, we'll have a horizontal tangent when the slope is 0. So what we're going to do is set the derivative equal to 0. So factor out a 4x. That leaves x cubed or x squared minus 1. So that becomes 4x, x minus 1, x plus 1. So the zeros will occur when x is 0, x is 1, and x is negative 1. So does the curve have any horizontal tangents? Yes. It has 3 at 0, 1, and negative 1. So we'll have 3 horizontal tangents. And shouldn't that make sense? If you have a quadratic, it has 1 extrema. If you have a cubic, it has 2 extremas. So if you have a quartic, it should have 3. So the extremas of the original are when the derivative is equal to 0. Extremas on the original are when the derivative is equal to 0. All right. So the question becomes, is it true that the product of the derivatives is equal to the derivative of the product? So I know that's kind of worded. Is it true that the product of the derivatives would be equal to the derivative of the product? So we took the derivative of the product on our notes yesterday. So, or today, I guess, for the x plus 5 squared example. So we took a binomial being squared, we factored it out, and then we took its derivative. So what we're going to do right now is compare. So we have 2 functions. We have f and g. And what we want to do is the derivative of f would be 4x, and the derivative of g would be 4. So what we want to do is compare is the derivative of each function individually multiplied together the same as if we multiplied the 2 functions together originally and then derived it. So if I wanted to find the derivative of, so we have f of x times g of x, and I want to know what its derivative is. So that's our ultimate goal. We want to know what is the derivative of f of x times g of x. So the derivative of f is 4x, derivative of g is 4. Let's first multiply f of x times g of x. So this is what yesterday's will look like. Here's your problem. You're saying, okay, I want the derivative of this. So let's FOIL it. So you get 8x cubed plus 12x minus 2x squared minus 3. So the product, and now let's take the derivative of the product. So derivative of 8x cubed, power rule says it'd be 24x squared plus 12 minus 4x, and then the 3 goes away. What would the 2 derivatives be multiplied together? You get 4 times 4, which is, so is the derivative of the products the same as the product's derivative? No, right? These aren't the same. So which one's correct? Which one do you think we have to do? Do we derive separately and then multiply? Or do we multiply and then derive? It's going to be the harder of the 2, right? So it's going to be the multiplying and then divide. Because the question is, you want to know what the derivative of the products is. This is taking the derivatives and multiplying them together. So this right here represents f prime of x times g prime of x. But it does not represent the derivative of the product. So this is the right method. So that's going to lead to the product rule because we do not want to FOIL every time we have to do a product, right? Like, what if this was a trinomial? What if this was something cubed? So what we're going to do is come up with a formula. And that formula is called the product rule. The product rule says it's the derivative of a product is the first function. So in this case, the first function is f of x. So you're filling this in like that blank box space. So it's the first function multiplied by the derivative of the second function. So here's the second function. So it's first times derivative of the second plus the second times derivative of the first. First times derivative of the second plus second times derivative of the first. First times derivative of the second plus second times derivative of the first. That will be in your head every time you do a product. First times derivative of the second plus second times derivative of the first. Like, do you remember learning quadratic formula to Pop Goes the Weasel? What? We'll play it.
We made our own. Yeah, we made our own. Yeah.
Really? I always put Pop Goes the Weasel. Like, yeah, it's like Pop Goes the Weasel. Yeah, I play it to quadratic formula. All right, so first times derivative of the second plus second times derivative of the first. First, second. So I'm going to try to do it switching my colors, but my board's really off calibration. So, y prime will equal the first exactly as it is times the derivative of the second. So what is the derivative of x cubed? Perfect. 3x squared. The derivative of 3 is 0. It's gone. So first times derivative of second plus the second. So you literally just rewrite the second now. So it'll be x cubed plus 3 times derivative of the first. So what is the derivative of x squared? What's the derivative of 1? And now you just clean it up algebraically. So literally, once again, calc is done. And where are we? We're back in algebra. So 3x squared times x squared is 3x to the fourth. 3x squared times 1 is 3x squared. Distribute the 2x, so you get 2x to the fourth. And then you get 6x. Combining like terms, we get 5x to the fourth plus 3x squared plus 6x. So that's using the product rule. If you forgot about the product rule, or let's say you just didn't think the product rule was the method you wanted to do, you could FOIL the two together. So we could have from the very beginning FOILed these. So x cubed times x squared is x to the fifth. X cubed times 1 is x cubed. 3x squared plus 3. So again, I manipulated the original by FOILing, getting rid of the parentheses, and then I could have taken the derivative. And if I've done both methods correctly, the derivative better be the same. So the derivative of x to the fifth is 5x to the fourth. X cubed is 3x squared. And 3x squared becomes 6x. Derivative of 3 is 0. So here's the thing. The product rule exists, and there's times when the product rule is way easier than FOILing. But there are times when FOILing is way easier than the product rule. So 3 lines of work versus 2. So the idea is we have this method, but it's not always the smartest method. You have to start to learn which one is the best choice for this problem. And the best way to learn it is through the practice and repetition that we're going to look at. So if you see a problem like this and you're like, wow, FOILing it and deriving it would be way easier, that's still acceptable. Like, just because we've learned something new doesn't mean we forget the old. Okay? So let's look at example 2. Y prime, it's first, so you leave it as it is. Now, I have a tendency to say I hate square roots. I hate writing them. I hate what they look like. I also think they're confusing, but I know some people don't like powers. I rewrite my square roots as x to the 1/2. Neither one is right or wrong. It's just a preference for me, because what happens is once I have to FOIL, I think it's easier to add exponentials than it is to try to look at a square root. So first times derivative second. So derivative of 2x squared is 4x. 5 is 0. Plus the second times derivative of the first. So the derivative of square root x is gross. It's 1/2 x to the negative 1/2. Derivative of 2x is 2. And now it's algebra. Product rule is done. Now we got to clean it up. So 4x times x to the 1/2. The rule is that we add the exponents together. So you get 4x to the 3/2. Perfectly acceptable. 4 times 2 is 8. X times x is x squared. 1/2 times 2, 1. X squared minus 1/2 leaves x to the 3/2. One half x to the negative 1/2 times 5 gives 5 over 2 x to the 1/2. I'm a little lazy. I like to just drop it down now. 2 times 2 is 4 x squared, and 2 times 5 is 10. One more line where I can combine like terms, right? So 4 and 1 is 5x to the 3/2. 8 and 4 is 12. X squared plus 5 over 2, and if you like that square root symbol, you can write 2 square roots of x plus 10. Okay, that is the product rule.